So for the beginning of this screencast, we're going to show some basic, easy ways of doing some stoichiometry problems. You can see that I have a balanced equation already given, and we're going to reference that equation for the next few problems. So it is balanced. It must be balanced. We're going to pay attention to the coefficients, and in the problem I will show how to identify what we're given, what we're trying to find, and how to set up a problem. So the question is asking how many moles of aluminum. So when it asks how many moles, you put X moles over what you're trying to find. This way you have a visual of where you are. It says, oh, it wants to know how many moles of aluminum chloride, so that's in the wrong place. So this needs to be X moles here. When 2 moles of hydrogen chloride are reacted, so we put 2 moles here. Now on a mole-to-mole problem, and this is mole-to-mole because I'm given moles and I'm asked to find moles, so you don't even need your periodic table for this part of this kind of problem, because what you'll do then is use the coefficient and put it on the denominator side. So our final setup will look like this. 2 moles of HCl over 6 moles of HCl is equal to, because that's where that would be, X moles of aluminum chloride over 2 moles of aluminum chloride. Because in stoichiometry, everything is related based off of moles. And so from here, you would solve for X. Okay? So, since we have an equal sign here, we'll cross multiply. That gives me 6x is equal to 4. And we can follow with the units, and then you would even see that the units cancel too. And I will let you, so that gives you x is equal to 4 over 6. As a decimal, that would be 0.67 moles. And that would be your answer. And that's how you set up a mole-to-mole problem. On the next one, says, we're still using the same equation, calculate the number of grams of hydrogen produced from 3 moles of aluminum. I'll switch a different color so we can follow it through with that. So I'm going to erase this because it was the last problem. Calculate the number of grams of hydrogen produced from 3 moles of aluminum. So I'm starting with 3 moles of this, and I want to know X grams of hydrogen gas. Anytime you're given mole, all you need to do is put the coefficient underneath. Now this says grams, so I have to find the molar mass. I'm going to put that in parentheses. I'm going to put the coefficient because I have 3 moles. I need to know how much do 3 moles weigh. Well, every hydrogen mole H2 would be 2 grams. So that gives me a setup of 3 moles of aluminum over 2 moles of aluminum is equal to X grams of hydrogen gas over 3 times 2, that's 6 grams of hydrogen gas. Since it's an equal sign, I can cross multiply. It gives me 2x is equal to 18. So I would divide by 2. 18 divided by 2 is 9, and the unit this time is grams of H2. Now this next problem, let's go view, put a split in the screen here. Maybe. Now in this next problem, we're being asked about mass and mass. So that's going to be a little different. We're going to have to use our periodic table a bit more on this one. So I'm going to clear the last problem. We'll go to another color here. So it says how many grams of aluminum, that goes here, maybe, X grams of aluminum to produce 17 grams of hydrogen. So I want 17 grams here. And because it is mass and mass, I'm going to have the periodic table both times. So I bring down the 2 always. You always bring down the coefficient. But now I have to look up the molar mass of aluminum. And the molar mass of aluminum, if it's rounded to a whole number, is 27 grams per mole. Again, mass, I'm going to bring down the coefficient. 2 H's is 2 grams. And so that's now my setup for my mass-to-mass problem. So X grams of aluminum over, you can multiply this out in your head if you like, or you can leave both numbers. It doesn't matter. I'm going to multiply these two out. So 54 grams of aluminum. That's equal to 17 grams of hydrogen over 6 grams of hydrogen. Okay, so what this is showing me on the bottom is that for every 54 grams of aluminum, I would get 6 grams of hydrogen. The problem's asking me, though, I want 17 grams of hydrogen, so how much of this aluminum do I need to start with? Okay, so I'm going to cross multiply. I'm going to do it this direction first. That's why I have my 6x on this side is equal to, and I'm going to write 54 times 17 here. Okay, to finish solving this, I would divide this side by 6 and this side by 6. And so now I'm going to use a calculator off to the side. And that's 153 grams of aluminum. And that's all there is for doing, and I'm not going to lie, this is the easy way to do stoichiometry. You're doing all the same setup that you would do in a traditional problem. You know, we're taking the moles and we're taking it and we're multiplying it by the molar mass. You would do that step in a traditional problem. This was taught to me by someone who had to use a slide rule. And this is much easier. It's kind of a shortcut method because you can even do something like this. When I do this, I see that this simplifies. Okay? And now you don't even have to do a division. You're just doing 9 times 17. All right? So those of you that have a bit of a math phobia, if you can balance an equation and read the problem and put what you need and what you know in the right place, this really isn't terrible. Just don't tell everybody because stoichiometry, you know, sounds scary and sounds important. So we'll do some more in class and we'll do more practice, but this is about as scary as it gets.